Picture this. Beneath the geysers, the bubbling hot springs, and the serene meadows of Yellowstone National Park, there's a restless giant. It's not sleeping. It's alive, shifting and pulsing with forces we can barely fathom. Deep under the surface, a colossal magma plumbing system churns, and the faint tremors of deep Earth seismicity are like its heartbeat, revealing secrets about one of the world's most watched supervolcanoes. What's happening down there, and why does it matter? Let's dive into the fiery, dynamic underworld of Yellowstone and find out. Yellowstone isn't just a national park. It's a supervolcano, a geological titan capable of eruptions so massive they could alter the planet's climate. Its caldera, a cauldron-like depression formed by past eruptions, spans roughly 30 by 45 miles. That's a lot of restless Earth. But what makes Yellowstone so fascinating and a little unnerving is how it's constantly in motion, not just at the surface with its geysers and hot springs, but deep below, where molten rock ebbs and flows like a subterranean tide. These movements are tracked through deep Earth seismicity, the study of earthquakes and tremors originating far below the surface, often 20 miles or more down. These aren't the quakes you feel on a hike. They're subtle, often undetectable without sensitive instruments, but they're key to understanding Yellowstone's hidden dynamics. Let's break it down. Seismicity is just a fancy word for earthquake activity, but when we talk about deep Earth seismicity, we're looking at quakes that happen way below the crust, in the upper mantle or even deeper. In Yellowstone, these tremors often originate in the complex network of magma chambers and conduits that make up its plumbing system. Think of it like the pipes in a massive, ancient house. Except these pipes carry molten rock, and they're constantly shifting, cracking, and adjusting under immense pressure. These deep quakes are different from the shallow ones that rattle your coffee cup. They're caused by the movement of magma, the fracturing of rock under stress, or even the injection of fluids like water or gas into cracks deep underground. Scientists use seismometers, super-sensitive instruments scattered across Yellowstone, to detect these faint rumbles. By analyzing the speed, direction, and strength of seismic waves, they can map out where the quakes are happening and, more importantly, what they're telling us about the magma system below. So, what does this plumbing system look like? Imagine a sprawling network of chambers, channels, and reservoirs filled with molten or semi-molten rock, stretching from just a few miles below the surface to depths of 50 miles or more. Yellowstone's magma system isn't one giant pool of lava waiting to erupt. It's a complex, multi-layered setup. There's a shallow magma chamber, maybe 3 to 10 miles deep, that feeds the park's famous geothermal features like Old Faithful. Deeper down, there's a much larger reservoir of partially molten rock, connected by a maze of conduits that carry magma, gases, and heat. What's wild is how this system is always changing. Magma isn't static. It moves, cools, crystallizes, or gets replenished by new molten rock from deeper in the Earth. Deep Earth seismicity gives us clues about these shifts. For example, a cluster of deep quakes might signal magma pushing into a new chamber or fracturing rock as it moves. In 2017, scientists noticed a swarm of deep earthquakes beneath Yellowstone, some as deep as 30 miles. These weren't signs of an imminent eruption, but rather hints that the plumbing system was adjusting, perhaps as new magma flowed in or as pressure shifted in the mantle below. You might be wondering, why care about quakes we can't even feel? Because they're like a window into Yellowstone's soul. By studying these deep tremors, scientists can piece together how the supervolcano works, how it's evolving, and, crucially, whether it's showing signs of waking up. Yellowstone's last major eruption was about 640,000 years ago, and while a catastrophic eruption isn't likely anytime soon, the park experiences thousands of small earthquakes every year, most of them shallow, but some originating deep in the plumbing system. These deep quakes help us understand the bigger picture. For instance, deep seismicity can reveal whether the magma chambers are growing, shrinking, or staying stable. If a lot of deep quakes cluster in one area, it might mean magma is on the move, potentially feeding the shallow chamber that powers Yellowstone's geysers. Scientists also use these tremors to map the structure of the plumbing system. Using techniques like seismic tomography, think of it as a CT scan of the Earth, they can create 3D images of the magma reservoirs based on how seismic waves travel through different materials. Molten rock slows down waves compared to solid rock, so these images show where the magma is and how it's distributed. Let's get a bit poetic for a second. Yellowstone's deep earth seismicity is like a dance, a slow, powerful waltz between fire and earth. The magma moves, the rocks crack, and the planet responds with tremors that ripple through the mantle. This dance has been going on for millions of years, shaping the Yellowstone we know today. The park sits atop a hotspot, a plume of hot material rising from deep in the Earth's mantle. This plume has been feeding magma to the surface for at least 17 million years, leaving a trail of ancient calderas across Idaho and Wyoming as the North American plate drifted over it. The hotspot is still active, and deep seismicity is one way we see its influence. In 2020, researchers found evidence of a magma body about 25 miles deep, much larger than the shallow chamber. This deep reservoir might be the source of the magma that keeps Yellowstone's geothermal features going. When deep quakes occur, they could indicate that this reservoir is refilling or shifting, sending pulses of heat and material upward. It's not just about eruptions. This activity also drives the geysers, hot springs, and mud pots that make Yellowstone a geological wonderland. Here's where it gets real. Yellowstone is one of the most monitored volcanoes on Earth. Scientists at the Yellowstone Volcano Observatory, YVO, track every tremor, no matter how small, using a network of seismometers, GPS stations, and satellite data. They're not just watching for eruptions, they're trying to understand the system's behavior. Deep Earth seismicity is a big part of that. By studying these quakes, the YVO can detect changes in the magma system, like if it is becoming more pressurized or if new magma is flowing in. This monitoring isn't just for science nerds, though it's pretty cool if you're one. It's about safety and preparedness. While a supervolcanic eruption is unlikely in our lifetime, smaller volcanic events like lava flows or ash explosions could happen with less warning. Deep quakes give scientists a heads up about what's happening below, helping them assess risks. Plus, understanding the plumbing system helps predict how Yellowstone's geothermal features might change, which matters for the millions of visitors who flock to the park each year. Studying deep Earth seismicity isn't easy. The deeper you go, the harder it is to pinpoint exactly what's causing the quakes. Is it magma moving? Fluids like water or gas? Or just the Earth's crust adjusting to the immense heat below? Scientists often combine seismic data with other clues, like ground deformation measured by GPS or gas emissions, to get a fuller picture. But there are still plenty of mysteries. For example, we don't fully understand how the deep and shallow magma chambers are connected or how often new magma flows into the system. Another challenge is the sheer scale of Yellowstone's plumbing. It's so vast and complex that no single model can capture it all. Deep quakes might happen in one part of the system while the rest stays quiet, making it tricky to interpret what's going on. Plus, the deeper you go, the less precise the data gets. Seismic waves get messier as they travel through layers of rock, magma, and fluid. So, where does this leave us? Yellowstone's deep Earth seismicity tells us the supervolcano is alive, dynamic, and constantly reshaping itself. It's not about to blow, but it's far from dormant. Scientists are getting better at interpreting these deep tremors, using advanced tools like machine learning to spot patterns in seismic data. In the coming years, we'll likely get an even clearer picture of Yellowstone's plumbing system, thanks to new technologies and more sensitive instruments. For now, the deep quakes are a reminder of the incredible forces at work beneath our feet. Yellowstone isn't just a pretty park. It's a window into the earth, a fiery heart. Every tremor, no matter how faint, is a clue to the supervolcano's past, present, and future. So next time you hear about a quake in Yellowstone, don't just think of it as a random shake. It's the earth whispering its secrets, and we're just starting to listen.